Beautiful, isn't it? It's one of my favorite places. As a water manager or policy maker of this area, you might be responsible for the very hard decision: do I allow this nice dune area to be turned into irrigated cropland? I mean, people do have to eat. And then that decision, you may wonder, what would happen with the hydrology of this place? What will happen with downstream discharge in the river of this place? As a policymaker, you most likely have a data scientist on staff whom you could ask that question. And the data scientist will most likely be familiar with tools like Jupyter notebooks, but not necessarily with the latest state-of-the-art hydrological models. With the eWaterCycle platform, we have built the tools for this data scientist to be able to work with the latest hydrological models in a Jupyter notebook environment. And that would look like something like this.
Hello, my name is Nick Wendegiesen and I'd like to show you how the eWaterCycle project works. First, we simply open a Jupyter notebook. Many models are readily available. Here we use PCR Glob for the basin of the Merrimack River in the United States. We first load the settings. Even though the model runs in a high-performance computing environment, the calculations for 2 years still take some time, so the following results were calculated earlier. But in principle, one just walks through the notebook. First, we run a reference scenario with standard forcings that are also available within the eWaterCycle system. Here you see the moisture distribution in the model domain. We have selected one point on the river to calculate the river discharge. The results can be seen here. Now we can make changes in the model setup. Just as an example, we irrigate this patch within the basin and run the model again. Immediately you can see the impact such a scheme would have on the downstream river discharge.
And that's it. We can never tell you if it's worth it to turn this dune area into irrigated cropland. That is a political decision where values come into play. But with a platform like eWaterCycle, we can give data scientists working for policymakers the tool set to base that decision on solid science, working with hydrological models that otherwise they wouldn't have access to.